hardware of Apollo. We're in an HD age, and it's going to the planets.
So until the day comes when we can all take a rocket ride into orbit, sit back and enjoy the amazing HD TV views from above.
And we think our signal is through now. It looks like the crew is ready. Commander Mike Lopez Alegria is standing by in the Destiny Laboratory aboard the International Space Station to bring us the first ever live downlink from space in HD. Mike, can you hear me out there?
I hear you loud and clear, Robert. How do you hear me?
Okay, I hear you very well, and we'll explain to our viewing audience that because the distances involved here, they're 215 miles away, so there's just a little delay in the back and forth. Mike, show us what you can. You're in the Destiny Laboratory there, right? Can you take us on a little tour of what it looks like?
You bet. This is actually the Unity node, which is attached to the Destiny Laboratory. We'll be going there in just a second. But this is one of about 6 habitable volumes that we have on board the space station. My crew of 3, Thomas Reiter from the European Space Agency, who is behind the camera, so you can't see him, and Mikhail Turin, a cosmonaut from the Russian Space Agency. And I have been aboard for about 2 months or so. Actually, Thomas has been here a bit longer. And we basically spend most of our time doing experiments, operating, maintaining. It is to everybody on the ground. We use it not only for food and cooking, drinking, and hygiene, but we also use it to generate oxygen. So as you can see, it's sort of a very important consumable for us. And then above me on what would be the ceiling is our resistive exercise device, which is also sort of like a universal weight machine. And we use this as one of our exercise tools to keep us in good shape. I'll see if I can demonstrate here one of the exercises we might want to do. Of course, the loss of bone and muscle density in space is a very important consideration, so we have a couple of countermeasures we use to try to avoid that loss. See if I can do a couple bench press repetitions here. The resistance, of course, we can adjust with these cans, which basically it's just a great big rubber band that keeps the resistance wherever we need it. Actually very effective. Okay, we're going to head forward now from the Unity into the laboratory module. As you mentioned, the lab module is called Destiny. And this is where we do the bulk of our work here on the US segment. We have a number of experiments that are going on in here all the time. We do some operations from here, and I actually live here right now. Tomas and Misha live in the Russian segment in the service module. First stop here is our robotic workstation. We use this to control the space station's robotic manipulator system, otherwise known as the robot arm. You can see a couple of hand controllers, some monitors that we use to view our work as it's going on. Continuing forward, you see we have a lot of these laptops deployed. We actually control the station largely through laptops when we do it on board, although our team in Mission Control in Houston does most of that commanding. Here are a couple of experiments. One in particular is pretty interesting. This European delivered MELFI, which stands for minus 80-degree laboratory freezer. It's in fact closer to minus 100 degrees right now, and I thought I might show you where we like to keep our ice cream if we had any on board.
Mike, that's a new piece of equipment up there, right?
Mike, that's a new piece of equipment up there, right?
Yes, MELFI came up about 2 shuttle flights ago, and we're already using it to store samples of blood and urine that we're collecting for some experiments as well as some others. I'll give you a peek inside here. In case you can't tell on high definition, which I'm sure you can, it's quite cold.
How cold again was it, Mike?
In fact, it's frozen, it appears.
How cold again was it, Mike?
It's about a minus 100 degrees centigrade. So it's quite cold.
Yeah, I would not want to go out in that. But the fact that you got that freezer up there now enables you to store samples of your own blood for blood checks later, right? For determining bodily changes as you stay on the space station over a longer time?
Right. One of the things that we're very interested in, of course, is what happens to the human body as we are subjected to long periods of microgravity. And we can measure what we intake by basically notating everything that we eat or drink in a certain period. And then our blood samples correlate how our body is processing those. And of course, the blood samples we can't analyze on board, so we freeze them for later analysis on the ground.
How about the rest of the experiments?
Okay, right above me now is the European Modular Cultivation System. It's basically a couple of large centrifuge tables which can hold some biological samples, either plants or other tissues, that we can vary the effects of gravity by spinning them at various rates. There's all kinds of photographic and other recording equipment inside that can monitor what's going on with those samples as we use them. Immediately to your left is one of our 2 human research facility racks. There's equipment to measure gas intake. We use that a lot when we're doing exercise to try to understand how our bodies are processing, metabolizing oxygen, especially on board. I'm passing over one of our favorite spots in the laboratory, which is the window, which looks down over the Earth. We'll probably take a look at that a bit later.
Oh, you bet. We're planning on that.
Your left, again, is the CVIS, the Cycle Ergometer Vibration Isolation System. You see it appears to be floating. It's actually on a series of, vibration isolators, so that our loads that we put in when we're pedaling don't get transmitted to the structure and disturb the microgravity environment aboard the station. On the left, on your right, behind that other laptop is a microgravity science glove box that we can use. We would put our arms inside those 2, well, you can only see one of them, green circles there, to be able to work in an environment that might be hazardous to us, or in other way want to be protected from aboard. This is a very forwardmost part of the node. All this gear that you see here is stuff that has been pre-packed. It will be going home on the shuttle Discovery, which we expect in early December. And a couple of more experiments. This is called Altea, the Anomalous Long-Term Effects on Astronauts. This is basically a measurement tool to measure, I'll just call them cosmic rays, that we take on board. We actually put this EEG cap on and put our head inside this device, and we can correlate. Actually, there's some visual disturbances that occur, and we can correlate when they occur to when these sensitive sensors can measure impacts from cosmic energy. Lastly, this experiment is called SPHERES, Synchronized Position Hold. Let's see if I can get the rest of the acronym. I can't. Anyway, it is pretty neat. It's a satellite system. We have a couple of them, actually, and is one of our, in fact, I think it's the only DoD experiment we have aboard, but it uses CO2 gas to maneuver itself, and we can actually get these 2 satellites to fly in formation with each other and actually dock to each other. So that's a pretty fun experiment. We got to do that a little bit last weekend.
And I think I see the idea there that you couldn't do that.
Anyway, that's kind of a very rough overview.
Couldn't do it on Earth where there's gravity. You need to be in space. Are we able to move over to the window? Are you? Can Thomas move the camera over there and show us the view out?
Can Thomas move the camera over there and show us the view out?
Sure, you bet. He's showing you our laptop right now, which shows you where we are. Obviously, we are just crossed over the west coast of Africa after having passed through the North Atlantic. And he will now take the camera down into the lab window and show you exactly what it looks like from here. The terrain below, how would I say it? It is an experience that makes you really appreciate what we have down there, that it's fragile, that we need to protect it. And you feel very detached from it, and sort of you miss it. It's your home. It's where all your loved ones are, where all of your experiences have happened, and you really get a sense of being separated from it in a way.
Now, I think in terms of the imagery and experiments, people sometimes wonder, I mean, we have unmanned satellites that circle the Earth and take this kind of photography, but there's some advantage too to what you can do, right, with a human looking out there to where to focus in, where to take the shots?
Looking out there, where to focus in, where to take the shots?
Well, certainly the advantage that humans have over robots is that we can adapt quickly. We can, you know, respond to changing situations. For instance, my predecessor as science officer aboard on Expedition 13, Jeff Williams, managed to take a picture of a volcano that was erupting in the Aleutian Island chain, and even if they wanted to program a satellite to take a picture of it, nobody could know when it was going to happen or when the satellite would be there. It would take a while to get there. It was a very short eruption, and he managed to take a shot of it. So yes, we do have the ability to respond in more real time. And I think we also have a different sense of, you know, art in a way. We can take pictures that a satellite might not want to take because from a science standpoint, it might not be all that interesting, but we are all humans after all, and the pictures actually appeal to a different sense than
Mike,
just the
let's
science.
go to the food now. I think this is the fun stuff for viewers, I think. Can you show us how you manage up there? I mean, I can only imagine that it's very, very difficult in space where juices and things like that want to float all over the cabin, crumbs. But how do you deal? Just give us a little lesson in it.
How do you deal? Just give us a little lesson in it.
Well, you're right. I mean, it's different. It's some of it's challenging, some of it's fun. I've prepared a couple of items for your consideration. First of all, our food comes in a variety of different forms. Some of it is dehydrated, and some of it is thermal stabilized. Some of it comes in its natural form. This is soup before it's dehydrated. It doesn't look particularly appetizing. And this is soup. It's noodle soup with meat after it's been hydrated. It looks a little bit better. You can choose to eat this soup with a spoon if you'd like, but it's more practical just to use this sort of built-in straw device.
You know, that all looks so difficult, and I know studies have shown that eating is very psychologically important for crews on space stations where they're away from the Earth for a long time. Are you able to get some pleasure out of eating, even though it's a lot more difficult than on Earth?
Even though it's a lot more difficult than on Earth?
Absolutely. Well, first of all, you're right. Eating is extremely important, and it's the folks at NASA and the Russian Space Agency go to great lengths to try to, you know, accommodate our tastes and our what we think we're going to like on orbit. Of course, people's tastes tend to change. We tend to like things that are a bit more spicy. You can imagine that salt and pepper don't work so well up here, so we actually have our salt, pepper, soy sauce, and actually some wasabi in a different sort of a form. This is actually salt, and in order to apply it, you just remove the lid and squirt some. You can see some of it is caked on the outside, but you just sort of squirt some onto whatever your food is.
I got the idea there. If you were shaking it like a salt and pepper shaker, it'd go all over the laboratory, right? The crumbs, the salt and the pepper.
Yeah. Yes, the salt granules would definitely be problematic. Of course, these candy-coated almonds are a real treat. They taste about the same, but they're obviously a lot more fun. If you'd like, you could perhaps try one.
In high definition, that's something coming at us like that.
In high definition, that's something coming at us like that.
And then drinking, of course, this is what tea might look like, or what it does look like, before it's been hydrated. This is tea with sugar, so you can see the tea bag inside along with the sugar. And then once you hydrate it, we put about 200 milliliters or so of water in there, and it actually tastes quite good. Same idea in this. This is orange pineapple drink, and of course you got to be careful. I would be remiss if I didn't do the obligatory orange bubble trick.
Nice.
Nice.
Fluids in space end up taking the form of spheres to reduce the, or due to surface tension, and you can sort of play with it as much as you want. You can blow on it to get it to do certain things, but the best thing to do with it is to eat it or drink it.
So simple, that looks great.
We have some.
So simple, that looks great.
We have some fajitas on board that we could use. These are actually, obviously in its natural form, tortillas. So we would just take the tortillas and then take the fajitas, which I'll show you a shot of inside. Pretty appetizing. We have chicken fajitas, beef fajitas. There are probably over 200 different menu selection items, and we build our own menus. We eat each other's food. This one has a red dot on it. That means it's mine, but it doesn't matter. We eat each other's food, and we build a menu that supposedly goes by days.
So you're
but
moving pretty well
when
up
it's time
there.
to eat, you just look in the pantry, take out what looks good, and eat it. We do okay up here.
Mike, I think we're out of time, but I want to thank you a whole lot for taking time out of your incredibly busy work schedule to share a very special technology first with our viewers, seeing you live in HD TV. I mean, seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Robert, it was our pleasure, the Expedition 14 crew of the International Space Station Alpha, as well as the NASA team, to participate in this first ever HDTV event. We had a great time showing you kind of what it is that we do up here day to day, and we look forward to more of the same in the future.
Great, Mike. That was just a lot of fun.
Thank you and good day.
Good day to you.
Great, Mike.
You know, I've been covering the space program for many years, and I've seen the evolution of these live images coming back from space since the days of the Apollo missions. And I gotta say, this is truly amazing. So thanks everyone for watching. This has been a live broadcast special of Discovery HD Theater, a momentous technology first, the first live broadcast from the International Space Station in high definition. This is Robert Hager. So long from Discovery.